Consider the complex equation 2z to the 6 is 1 plus root 3i. We want to solve the above equation giving solutions in polar form r cis theta, where we only want to give those with theta between 0 and pi by 2. Okay, so let's look at 1 plus root 3i. So that goes 1 that way and root 3 that way, which will make this 2, 3 plus 1, square rooted, and the inverse tangent root 3 over 1, so this one is pi by 3. So we have 2z to the 6 is equal to 2 cis pi by 3 plus 2n pi. Remember, every time we land on it as we go round and round. Divide by 2, and z to the 6 is cis pi by 3 plus 2n pi. And so z would be cis pi by 18 plus 2n pi by 6, which is n pi by 3. So if n is equal to 0, we get z is equal to cis pi by 18. Pi by 18 is certainly in our range. If n is equal to 1, z is going to be cis pi by 18 plus pi by 3. Pi by 3 is 6 pi by 18, so that would be 7 pi by 18. That's certainly in our range, but no other values would be. If we go to 2n pi by, n is 2 pi by 3, that would then be outside this range of angles. So we just want these two solutions. Now consider the equation 2z to the n is 1 plus root 3i, where n is a positive integer. If 2z to the n is 1 plus root 3i has roots so that there are exactly 3 roots, and only 3, that lie within the first quadrant in the complex plane, determine the possible values of n. Well, we solved it in the z to the 6 case, so we know that we can write z to the n is cis pi by 3 plus, now I used 2n pi before, but then I'd have n using two different things, so I'm going to say 2m pi, where m is an integer. And then our z is going to be cis pi over 3n plus 2m pi upon n, like so. Now we want to figure out where there's 3 and only 3 of these between 0 and pi by 2. Now we can actually do this just by trial and improvement. We know that in the n equals 6 case we get two solutions. And if n is a smaller number, we're going to get either two solutions or less solutions because the angles that we're moving around by will be bigger. So we could actually try the situation where n equals 7. And so we would have pi by 21 would be one of them. And then with m equal to 1, we'd have pi over 21 plus 2 pi by 7. So 2 pi by 7 is 6 pi by 21, so altogether this is 7 pi by 21, which is pi by 3. But if we then do 7 pi by 21 and add an extra 2 pi by 7, we get 13 pi by 21, and that is more than pi by 2. So the third angle doesn't work, so it's still only two angles with n equals 7. We try n equals 8. We'd have pi by 24. And we know the next one's going to fit, so we won't worry about that. What about the next one? Pi by 24 plus, so we're taking m equal to 2 this time. So that would be 4 pi over 8, which is pi by 2, and that's more than pi by 2. So once again, we only got 2 angles that fit. And then we could try n equals 9. So we have pi by 27. We know the next one's definitely going to fit. What about the next one? Pi over 27 plus, so this would end up being, so we've got m equal to 2, so it's going to be 4 pi over 9, which is 12 pi over 27, which is 13 pi over 27, and that fits. That's less than pi by 2. If you go to the next angle, you'll find it doesn't. And if you continue to explore, you'll find that it works up until 12. So the values of n that work, 9 that we just found, 10, 11, and 12. But there must be a better way of doing it, so let's look at that. So, if we think about this situation here, what we're looking at is when the third angle fits. Now the first angle was the m equals 0, the second one's the m equals 1, the third one's the m equals 2. So if m is 2, what we're looking at is whether pi over 3n plus 4 pi over n is less than pi by 2. So we can cancel pi's right the way through here. So that gives us 1 over 3n plus 4 over n, which is 12 over 3n, is less than a half. So 13 over 3n is less than a half, which means that we need 3n to be greater than 26, and therefore n is greater than 9 because n must be an integer. But we also need the situation where we don't end up with the next root being in there, because we're only allowed 3. Now the next one is when m is 3, so this will end up being 6 pi over n. So we also need that pi over 3n plus 6 pi on n, we need that to be greater than pi by 2 for this to work. So this, would be greater than or equal to. So again, cancel the pi's, and then we've got 1 over 3n plus 6 over n, which is 18 over 3n. We need that to be more than a half. So that's 19 over 3n is greater than a half. And rearrange that, we need 3n to be less than 38. So n is less than or equal to 12 would do that. And so you can see that's a slightly more mathematical way of finding what we found by investigation before.